Trigonometric equations. What are they? How do we solve them? Here's an example of a trigonometric equation. We've got a trigonometric function that's equal to 0. If we think about it, we've talked about trigonometric functions before. 2 cos x take root 3 equals 0. Well, I'm not going to draw that exactly. But what we can think about that is if we have the function 2 cos x take root 3, what we're saying is if we drew that on an axis, and again, I'm not drawing this to scale at all, but if we've got the question 2 cos x take root 3 equals 0, we're really trying to find when that is equal to 0. So that function, which we could call y, when that is equal to 0. So we're trying to find the x-intercepts. We're trying to find when y is equal to 0, or we're trying to find the x-intercepts. So if you're ever asked to find the x-intercepts with a trigonometric function, what you're really doing is solving a trig equation. It just helps us when we're actually thinking about, well, what's going on. This is not different from what we've been doing. It's just an extension of what we've been doing. So if we've got this function, we want to find x. So how would you normally go about that? Well, you try and get x on its own. So let's do that. We're going to make this 2 cos x equals root 3. I've just added root 3 to both sides. Okay, so you wouldn't need to write this step in, but that's what I've done. I've added root 3. Then I want to get rid of the 2, so I'm going to divide by 2 on both sides. And I'm going to get cos x equals root 3 on 2. Now, if you got that question in a normal problem where you were doing a triangle or something like that, what you'd do is you'd put it in your calculator and you'd solve. Now we can do that, and I'm going to show you 2 ways you can go about solving this, and you just pick the way which makes more sense to you. What I'm going to do is do a tiniest little sketch of a unit circle diagram over here. I'm going to go cos x equals root 3 over 2. Well, I know cos x is actually the x value, so that's going to be there. Okay, I know that at both these points, this one here and that one there, I have an x value or a cos x value of root 3 over 2. So all I have to do is find out what angle that is, and I can read that straight off my unit circle diagram. So that means, therefore, that x is going to equal pi on 6 or 5 pi on 6, because that's the value when cos of x equals root 3 over 2. So I can go straight from that x is therefore equal to pi on 6. Or, if you look on your unit circle, it could also equal 11 pi over 6. Now, if you'll notice here, I'm not actually giving it a domain. I'm not giving any restriction on the value of x. So x could be any value. If you think about the revolutions around a unit circle, it could be that. Or you could do that plus 2 pi, plus another 2 pi, plus another 2 pi. So to represent all those different values, what we do is we go pi on 6 plus k2 pi. Similarly here, 11 pi on 6 plus k2 pi. First one done. Alright, another example, slightly different because we've got a period here. When I've got a value in front of my x or a horizontal translation, if I've ever got a period or a horizontal translation, I'm just going to call it x. Okay, I'm going to replace it and I'm going to just write out here, let big X equal 2x. That's just going to make it a little bit easier for me to work with it later, and I'll go back and put it in later. So I'll get 6 cos of x equals 3. So therefore I'm just going to solve it like before. I'm going to get cos of x equals 3 over 6. So cos of x equals a half. Now then, if I draw my unit circle here, I go okay, and I'd sketch this out, but you can also just look at your unit circle. When does cos of x equal a half? Well, cos of x equals a half at pi on 3 and at 5 pi on 3. So therefore big X equals pi on 3 plus k2 pi and 5 pi on 3 plus k2 pi. Now we've set up here let big X equals 2x, so I'm just going to bring that in I'm going to use this now because I've actually want to solve for little x. So I'm going to go, therefore, 2x equals pi on 3 plus k2 pi, and 5 pi on 3 plus k2 pi. Then I have to work out how I find x. To do that, I'm going to divide by 2. So x is going to equal pi on 6 plus k2 pi over 2. If I divide by 2, I have to divide both of them by 2. And then 5 pi on 6 plus k2 pi on 2. You might be wondering, where's the pi on 6 coming from? Well, that's pi on 3 divided by 2. So that's going to, x is therefore going to equal pi on 6 plus k pi, or 5 pi on 6 plus k pi. And that will tell you all the different solutions you can get for x. A tiny little bit trickier, but really not that much more working out there. Alright, sine of 2 theta equals negative 0.8. You'll notice here that it's got a slight difference. We've got a decimal, we don't have one of the values on the unit circle. How are we going to solve it? Well, again, we've got our x. We're just going to find x again, so let x equal 2 theta. So we get, if we do that, we get that sine of x equals negative 0.8. So then I'm just going to go sine to the negative 1. Now when I do this, sine to the negative 1 of this time of negative 0.8, I'm just going to ignore the negative. Okay, I can do that. I'm going to ignore the negative because I'm going to work out what that is using a unit circle. Okay, so just for now, I'm going to ignore the negative. Now, I've got sine of x equals negative 0.8. Why did I do sine to the negative 1? Well, I want to find big X, and if you think back to right angle trig, that's what you would have done. So if I do sine to the negative 1 of 0.8, the answer that I get is equal to 0.927. So again, I'm going to draw my little sketch, and I'm quite happy for you to chuck it in the middle here. I'm going to draw a sketch. This time I've got 0.97, so how do I know where that is? Well, that's 0 and that's 6.28, because 2 pi, you put that in your calculator, you would get 6.28. So just check that now. You get 6.28 for that, and over here instead of pi we get 3.14. So instead of decimals, I'm just going to use, instead of pi and 2 pi, I'm just going to use decimals. So 0.927, well, we know in the middle it's going to be 1 point something, so 0.927 is going to be somewhere here. We don't really need to know why. We don't need to know exactly where, but we can just put it here, and then by symmetry we can draw in the rest of the angles. That should be going through 0. Okay, now we've got sine of x equals negative 0.8. Okay, so that means sine is negative. So that means sine lies in here somewhere. It must be either this one or that one. Okay, how do we work out what that is? We've got sine of x equals 0.927. That means in here, that's 0.927. That's 0.927. By symmetry, that bit is 0.927. And that bit is 0.927. So that's a bit messy. But how are we going to work out what angles we have then? Well, x is going to therefore equal 3.14 here plus 0.927. It's also going to equal this angle here, the angle starting at 0 and going all the way around to that, which is of course going to be 6.28, take 0.927. Okay, so x is going to either equal 3.14 plus 0.927 or 6.28 minus 0.927. There are two options. Now you might go normally, oh, let's add k2 pi, but we've got to check if we've got conditions, and we've got this up here. We've got a condition that 0 has to be less than x, which is less than 6. So yes, you're absolutely right. Normally we would add k2 pi to this, but because we've got that condition in there, we know we don't need to in this case, okay? Because we know we're not going to get a number bigger than 6.28 or bigger than pi. So therefore our solution is going to be 3.14 plus 0.927. So we get our answers that x is going to equal 4.067 or 5.353. Now then I want to make sure my domain's right, so as always I'm just going to put add k to pi, and we're going to sort that out in a sec, add k to pi. Now remember though, we're trying to find theta, and we know 2 theta equals that, so we're going to get 2 theta is equal to 4.607 plus k to pi, or 5.353 plus k to pi. And so then we've got to find theta. To do that we divide by 2, so we get theta therefore equals 2.03, or theta equals 2.677. because I'm rounding up. Okay, because I'm dividing by 2, and I'm just going to put plus k pi plus k pi. Now when we add in k pi, we just have to remember that we've actually got this restriction on our domain, that 0 is less than x, which is less than 6. So we can't go any bigger than that, right? You can try, but you can't really go any bigger than that. You can't go any bigger than 6. So I'm just going to add 3.14 because I'm adding k pi. So theta is going to equal 2.03. Then that plus 3.14 is going to give me 5.17. So that's all good. That's between it. And then if I go 2.677 and I added 3.14 to that, I get 5.817, so that's also okay. So our solutions do depend on, the number of solutions do depend on if we've got a domain or not. If we've got a restriction on the value of x, that really should be the value of theta, then we of course can't go over that restriction.